morning. Today I will teach you on the conditional property. So you can turn to page, the conditional property on page 87 and 86 and 87. So we are still in chapter 4, and then I can say these are part B. So this is the conditional probability for the continuous random variable. So you can refer to page 86. Now, by definition, the conditional probability, by definition, the conditional probability of f(x) given y is equal to f(xy), the joint probability, divided by f sub 2y, and this is the range here is f sub 2y must be greater than 0 elsewhere. Then the other part is this is a conditional property of x given y, and then the conditional property of y given x, we apply the same formula, is equal to, the numerator is the same, f(xy) divided by, because of this is a given x, so you put here as f sub 1 x. Then the condition here is f sub 1 x must be greater than 0 elsewhere. Example 4.15, page 87. So we are given the conditional property of xy is equal to xy over 9 for x between 0 to 2 and y between 0 to 3, then 0 elsewhere. Now I want to find the f sub 1 x. Then I want to find f sub 2 y. This is known as the marginal of x, marginal probability of x, and this is marginal probability of y. And then I want to find f(x) given y, and this is equal to f(xy) divided by f sub 2y. Then I also want to find f(y) given x, and this is equal to f(xy) divided by f sub 1 x. Then I want to find f(y) greater than 1 given x. So this is equal to f(xy) divided by f sub 1x. Okay, f sub 1x is equal to, so f sub 1x is you differentiate with respect to y. So I have to differentiate with respect to y. F sub 1x is equal to, for the continuous property, f sub 1x is we differentiate with respect to y. The original function there is x y over 9 dy. So the range of y is from 0 to 3. So here I have x y square or raised to over 2 multiplied by 9. Then substitute for y equal to 0 and 3. So I have here 9x over 18 minus by 0, or so I have this is equal to 1 over 2x. So if I want to put in terms of the marginal property function of x, so I have to put here as a f sub 1x is equal to 1 over 2x. The range of x is x between 0 to 2 and 0 elsewhere. This is a f sub 1x. Now what about f sub 2y? F sub 2y. So f sub 2y is equal to, by definition, is the integration of fxy. So our fxy is xy over 9. We have to differentiate with respect to x. So here is the range here. The range for x is from 0 to 2, xy over 9 dx. So if I integrate this function, I will get x raised 2 over 2 multiplied by 9 y, then substitute for x from 0 to 2. So I will have 4y over 18. So this is equal to 4 multiplied 18 divided by 4 is equal to 9. So 2 over 9 y. So this can be written as, so the function here, so the final function here is f sub 2y. We can put as a 2 over 9y for y between, the range for y is between 0 and 3, and then you put 0 elsewhere. This is how we solve the margin of x and margin of y. Then from here we can solve the conditional property of x given y. So the conditional property of x given y, f x given y is equal to f xy divided by f sub 2y. So we know that the fxy, the conditional property of x and y, the conditional property is equal to xy over 9 divided by f sub 2y is equal to 2 over 9y. 2 over 9y. So I have here, we can cancel off this one and this one. So this thing and this thing So the final answer here is x over 2. So the final answer here is x over 2. So in terms of the property, you can write down here as a fx given y. So x over 2, and then the range of x is in between 0 to 2 and 0 elsewhere. Okay, the next part is I want to find the conditional property of y given x. Conditional property of y given x. So f y given x is equal to the joint property x and y divided by f sub 1 x. So the joint property is xy over 9 divided by f sub 2x is equal to x sub 2x is equal to, here is, if we go here, you have f sub 2x is equal to x over 2. X over 2. X over 2. So this will give me the result of x y over 9 multiplied by 2 over x is equal to 2 over 9y. This is the final answer for the condition of y given x, and you can write them off and 0 elsewhere. And this is how we write the conditional property of x and the conditional property of y. So this is a x given y, and here is a y given x. The answer for x given y and y given x. And the last part is I want to find the conditional property of y greater than 1 given x. This can be written as fxy over f sub 1x. So fx given y. So previously we have as f given y is y given x. Y given x is 2 over 9y. So we just plug in here is 2 over 9y, and the range here, we know the range for y. The range for y is, because of here is y is in the numerator is y here. The range of y here is from 0 to 3. But this one, we want to find y greater than 1, meaning to say the range here is from this range is you have to integrate from 0 to 1 to 3, because of this greater than 1. So greater than 1 means from 1 to the maximum part is 3. So we integrate with respect to y here. So I will have, if I integrate here, we'll have y raised to 2 over 2 multiplied by 9. So substitute for y equal to 1 and 3. So this will give me the answer of, so 2 and 2 can be cancelled off. So I have here 9 over 9 minus by 1 over 9. So this will give me the answer of 8 over 9. This is the answer for part E. Y greater than 1 given x. Now look at the example 4.16. The next example is example 4.16. Example 4.6. So now example 4.6 we have 4 point example 4.16 page 89. Now for this example we are given the joint function here, joint probability function f(x, y) is equal to 3 over 2 y minus 1. The range for x is in between 0 and y, x in between 0 and y, and then I have y in between 0 and 2, then 0 as well. Okay, I want to find the condition, the margin of x. In other words, I want to find f sub 1x. Then I want to find f sub 2y. I want to find the condition of x given y, x given y. Then I need to find the condition of y given x. Then the last part is I want to find the probability of the function of y greater than 3 over 4 given x equal to 1. So we try to solve one by one here. So first is f sub 1x. Then we solve f sub 2y, x given y given x, and the last one is y greater than 3 over 4, where x is equal to 1. Okay, the first one, f sub 1x. So f sub 1x by definition is equal to integration of fxy dy. Integration of xy dy. So I have here the range of y is from 0 to 2. This function is 3 over 2 y minus 1. So dy. So this will give me an answer of 3 over 2 y raised 2 over 2 minus by y. Then you substitute for y from 0 to 2. So this will give me the answer of 3 over 2. 2 squared is 4. 4 over 2 is 2. Minus by 2. Minus by 3 over 2. 0 minus by 0. Sorry, the range here is not because of our limit there. The limit for x here. So this wrong. Now, the limit for x, we have to refer to the limit of x here. So the limit of x is from 0 to y. Then the y is from 0 to 2. Okay, so we cannot simply take a limit of y here 0 to 2 because of this limit relate with the above limit. So if you draw a curve there, if you draw a curve here, how to solve this one? If you draw a curve, this is quite a tricky equation. If you draw a curve there, so I have first one, I have from 0 to 2, y is from 0 to 2, and the other one is x is equal to y. So our area is this part. So we need to say my x is from 0 to x. The range for x is the range for x is from 0 to y. 0 to y. The range of x. While the range for y is not from 0 to 2. Now the range for y here is 2. Let's say here is 2. The range for y is from x. This is x. This x to 2. X to 2. So we have to change here. Instead of 0 to 2, the range for y is from x to 2. The range for y is from x to 2 instead of 0 to 2, because we have to consider this line. If you put 0 to 2, meaning to say we are looking this area. Here is 0 to 2. Here is 2. Here is 0. Here is 0 to 2. But we have, in this case, we have the graph, this is the area. But in this case, the graph is like this. You want to find this area, this particular area. So this particular area is 2. So your y here is from this particular thing, this particular line is from x to 2. X to 2. So if you put 0 to 2 is this area. But because of there is a line there, so the point here is the graph here is from x to 2. So that's why we have to integrate from x to 2, 3 over 2 y minus 1 dy. So this will give me the answer of 3 over 2 y raised 2 over 2 minus by y. Substitute for y is equal to x and y is equal to 2. Now, if I solve this equation or this problem, okay, so I solve here, I will get the final answer here is 3 over 2. So 4 divided by 2 is 2. 2 minus 2 is equal to 0. Minus by 3 over 2 y is equal to x. So x raised 2 over 2 minus by x. So this is the equation here. And the thing here become, so if you simplify this thing, we get this will give you an answer of negative 2 over 2 multiplied by negative x is plus 3 over 2x, then minus by 3x raised 2 over 4. Okay. Or you can simplify this equation as you can simplify this equation. Okay, or you just leave like this. This is the answer. And the range here, the range for x is the range for x is from 0 to 2. Okay, the range of x is from 0 to 2, and you can put 0 elsewhere. Okay, this is an answer. Now B. Now I want to find f, the margin of x, margin of y, f sub 2y. So this is equal to, so f sub 2y by definition, we integrate the joint property function with respect to x. And this will give you the integration of the original function is 3 over 2 multiplied by y minus 1, so dx. So the range for x is from 0 to y. The range for x is from 0 to y. So if I integrate here, we get 3 over 2 y raised 2 over 3 over 2 integrate with respect to xy minus by x, then substitute for 0 to y for all x. Okay, so x is equal to 0 and x is equal to y. You just put here as a 3 over 2. So x is equal to y multiplied by y minus by y, then minus by 3 over 2, 0 minus by 0 is equal to 0. So this will give me the answer of 3 over 2 y raised 2 minus by y. You just can leave the answer like this, and here we can put bracket here. So the range of y is from 0 to y is from 0 to 2, y is from 0 to 2, and 0 elsewhere. Okay, this is how we solve B. And then we go to C. So I want to find fx given y. C is fx given y. So by definition is the joint property of xy divided by the marginal of y. And then you can write here the original function of fxy. The joint property is 3 over 2 y minus 1 over the marginal of y. The marginal of y we have just now is 3 over 2 y raised to minus y. So if you solve this one, we'll get, so this can be solved. So this can be written as y minus 1. So you can simplify this thing, y minus 1, or in other words, we will have 1 y. The last question here, I want to solve E, where E is, we want to find f y greater than 3 over 4, then given that x equal to 1. So by definition, this can be written as fxy divided by f sub 1x equal to 1. Now, we know that the range for y is from x to 2, and so if I solve this one, I need to integrate this function. The initial function is this is equal to 2y minus 1 over 2x minus by x squared. 2x minus by x squared. Now, so the bottom here, so every and each x here, we substitute a value of 1. So this will give me the answer of 2y minus 1 over 2 multiplied by 1 minus by 1 raised to 2. So this will give me the answer of 2y minus 1 divided by 1. Then I integrate, because since my range here, y is greater than 3 over 4, so the bottom limit here, the lower limit here is x, this is the lower limit, and here is the upper limit. Okay, the lower limit here is x, so my range of y here, y is greater than 3 over 4, mean to say we integrate here, we integrate this function 2y minus 1, we integrate from 3 over 4 to 2 dy. So this will give me the answer of, if you integrate this one, you will get y 2 raised to 2 over 2 minus by y, substitute for 3 over 4 and 2. So this will give me the answer of, so if I substitute the value of 2, I will get 2 multiplied by 4, this one is y is equal to 2, so 2 multiplied by 0 minus by 3 over 4 is 2 multiplied by 3 over 4, 3 over 4 square, so 9 over 16, 9 over 16 multiplied by 2 is 9 over 16, divided by 2 is 9 over 16 multiplied by 2 minus by 3 over 4. So this will give me the answer of, so if you multiply this one, you get negative 9 over 16 plus by 3 over 2, so negative 9 over 16 plus by 24 over 16, or the final answer here is 15 over 16. This is the final answer for question E. So I think that's all for today's lecture. So you can refer to my book Please do question number exercise 4.2 on page 91. Then you can try to solve question 1 to question 6. Assalamualaikum warahmatullahi wabarakatuh.